Alright, welcome back to what will probably be the last video of Section 3. It sounds exciting, it's probably not going to be. This episode is going to be a little bit of house cleaning at the very beginning, and then we're going to show how to connect to the Postgres database that we talked about before in the last video, and actually start storing some stock data. So we're going back to the same exact example, the stock data example from the beginning of this section where we were scraping Yahoo. We're going to start off right where we left off before. And let's take care of some house cleaning first. I actually technically left the last section a little bit unfinished. So there are a couple of things that we need to do. First off, we need to change the password for our testDB user to be password. I'll repeat the same disclaimer that I had before. Do not do any of this stuff the way that I'm doing it right now in prod, because it's insecure. I'm not designing it to be secure. I'm designing it to work in the most amount of environments humanly possible. So before you push any of this stuff to prod, before you expose it to the internet, make sure that you go through the proper avenues, talk to the right people, and do some research on how to actually secure this stuff. But for right now, let's make it a little bit more connectable. First, we are going to set the password. So let's go ahead and change over to -i-u. We're going to change over to the Postgres user, and we're going to run psql. And what we want to do, it's very, very easy. We're going to run the alter user command, and we're going to run it on the testDB user. We're going to say with password, and we list our password. Again, this is going to be very insecure. I'm literally using the password. But I'm making it easier to connect with, and you can feel free to do or don't do any of the steps in this section with regards to security and all of that fun stuff, because we're actually about to do something even worse than this. So we're going to press enter. It's going to say alter role. That means that it happened successfully. So let's exit this prompt, and we are going to change around some configuration files. First off, we are going to go to locate postgresql.conf. That is the configuration file for Postgres. We are going to do sudo nano etc postgresql 12 main, and if I can spell it, it's postgresql.conf. All right, so the line that you're looking for here is going to be right down here. Let me find it. I've already changed it, but I'm going to show you because you're going to run into this problem later on. This listen address is likely going to look a lot like this right here. And that's not what we want. And here's why. Postgres is set up to, by default, run on localhost only, which basically means that all of the code that you're running is going to have to be on the exact same machine, unless you set up tunnels and fun stuff like that. We're not going to do that in this section. Basically, it's just going to be listening on localhost. We're not going to be doing that. I am developing on my host machine while hosting a VM that has all of the backend stuff on it. So instead, we are going to change this over to star. And what that's going to do is it's going to run on localhost. So if I want to transfer any of my code over to the localhost, over to the VM itself, it will still run. But if I want to connect to it from my network, it will run there as well. Again, this is not the most secure way to do things, but I've got extra security mechanisms to secure my own home network. I say that, and somebody will probably prove me wrong later on. So we are going to save that. That is all we really need to change in that file. And we are going to find one more configuration file, and that is pg_hba.conf. Now this one's a little bit more complicated, and it's a lot more powerful. PostgreSQL 12 main pg_hba.conf. And this is basically what determines how you can connect to a given database. And it's got a lot of instructions here that give you a really great overview on how this file works, what you can do with it, what you can't do with it, all of that fun stuff. It is probably one of the more important files when it comes to securing Postgres. But like I said, we are not going to be securing it. We're actually going to be making it significantly less secure by using this line right down here. I've already written it. And that is host all trust. I'm actually going to change this over real quick and do a quick test to see if this will work. O.O/255. That is basically only going to set these settings to my home network. I don't know if this is going to work, but it should. By service, PostgreSQL restart, and login password. And let's run the command pg_ls clusters and see if that works. It does not. I'm going to guess that it is that line, and I'm going to change it back over to all and run our restart again. I will do some more research later on to figure out the best way to do this, but for right now we're just going to make it accessible like that and restart it again. And run pg_ls clusters, and we get all green. Now, we can actually get to the code. Now our database is set up. It's going to allow us to actually connect to it with the password that we set, and it is insecure as all hell, but that is okay because we are not pushing this stuff to prod. Please. So, there are 4 pieces of information that are important for us to connect to this database. We're going to have the database name. We're going to have the database user. We're going to have the database password. And we're going to have the database host. And those are the 4 pieces of information that we need to actually initiate the connection with our database. Our database name we set in the last video as testdb. Our username is the same. Our password we set as password. And our host is 10.0.0.8. This you will have to get from your virtual machine if you're doing the exact same thing that I am. Might be localhost if you're running your Postgres database on the same machine that you're doing your coding on. But you know, this is how it is set up with mine. So here are the things we've got to do. And we're going to do it right at the top of main. We're going to initiate the connection. We are going to create the table if it doesn't exist. And that's really about it that we're going to do right here at the top. So the way we're going to do this is through a library called psychopg2. And that is spelled this way: import psychopg2 as PSQL. We're also, on that same note, going to do import. We've already got time, so let's just, well, I thought we had, yeah, we've already got time. So let's just use time. I was going to import date time, but we don't really need that. So I'm importing it as PSQL. That's just kind of something that you're going to have to remember. We're going to set up our connection and our cursor. So our connection is the actual connection to the database. It's going to hold the 4 variables that we put up at the top. It's going to actually initiate that connection. Our cursor is going to be what we use to actually run queries across our database. That's going to become a little bit more clear here in a second, but with our connection, we're going to do psql.connect, and we are going to have our database equal to our DB name, our user equal to our DB user, our password equal to our DB pass, and our host equal to our DB host. Now, the default port is 5432. I'm going to list it explicitly just so you can start memorizing that port number. So that's going to create our connection. Our cursor is just going to be created like this, con.cursor. And it will become very, very clear how we're going to use that here in a second, actually. So this right here, we're going to leave blank for a second. We need to figure out the format of our data. Basically, the information that we want to store in this database. And let's do that in the form of a multi-line comment or multi-line string that's essentially a comment. We want to store an object with a ticker name. Well, first we need a UUID. That's very, very important. What a UUID is it's basically a unique identifier that's going to store each object in a database according to a unique string. So we want to create a unique string because we don't want to have duplicate items within our database, and we want some way to programmatically list and talk about each individual object. That UUID is going to be very, very important for that. So we'll have a ticker, we'll have a timestamp, we'll have a price, and we'll have a delta. So now we're going to get over here. All right, so now that we have our data structure, we can start creating our table. And the way that we're going to do this is basically at the beginning of our main function, we're going to run a query against our database that basically says if the table does not exist, how we've listed it out, go ahead and create it. Maybe not the best thing to do in, like, again, prod code, but it's going to be kind of like our way of introducing queries, our way of introducing commits, and our way of making sure that we do in fact have our table where we need it. So we're going to create an initial query. Query is like one of those words that I just constantly get tripped up on. And I'm going to write out the query and then explain it after I've written it out. All right, so a lot to unpack here. Let's go ahead and run through this query. So basically what we're saying is after we've connected to our database, we're going to look for a table named stock data. If it doesn't exist, go ahead and create it. And here is our data definition. Now, for the database people watching this, I understand that I created everything as text. And that's not the best way to do things, especially since we're dealing with numerical data. Completely understand that I'm doing that wrong. But I'm doing this basically for the sake of simplicity, and it's also relatively easy to convert those strings over to numbers anyways later on. But again, acknowledging that I'm not doing this the best way humanly possible, but this is how I'm going to do it. So our UUID, our timestamp, our ticker, our price, and our delta, we are going to make all of those text. As I just said, that's not the best way to do things, especially since our ticker, our price, and our delta are, well, no, our price and our delta are both going to be numerical values. It would make way more sense to store those as floats or as integers at least. But instead we're going to store them as text because I don't really feel like dealing with all of that. You kind of run into like making sure that those variables are in fact eventually converted over into floats or integers before you push them to the database. I don't feel like writing those extra lines of code because I'm lazy, so I'm just going to make them all text. So we've created our initial query here. These pieces of data are going to be the column names, essentially. If you're looking at like a CSV, these are going to be the columns and the rows are going to be the actual pieces of data. So we've defined our columns here as our UUID, which is our unique identifier, our timestamp, our ticker, our price, and our delta. So those are our columns. So we are going to do cur, which is our cursor, dot execute, and we're going to execute the initial query. So that is going to run the query against our database. We have to commit those changes through our connection object. Think like GitHub. So with GitHub, you can change all of these files around and you can actually add them to what is like basically the index. That's essentially equivalent to cursor.execute. Those changes don't take effect on any of your branches upstream until you actually commit them. So that's why we've got this con.commit. It is essentially the same thing functionally. So what this is going to do is it's going to create that table if it doesn't exist. Let's go back over here and let's do sudo tac u postgres and run psql test db. That is going to be our database that we're connecting to. So let's do coninfo to make sure that we are in fact connected to our test db. And let's do \dt, and that's going to show us what tables are currently present. Basically just showing you that I'm not actually, like I am actually creating this table here in a second. And what we're going to do down here is we're going to run a print statement that says successfully connected and created table. So that's going to tell us that we have successfully connected to our database and created the table as we've defined it right here in our initial query. All right, so that's already cleared out. Don't know why I'm trying to do it again. Let's run it. And as you can see, we successfully created the table. We're going to run through our scraper real quick. All of this is saving this data in our text files. So, well, I don't think it's actually even doing that. No, it's not. So it's not even saving the data into the text files. We're going to save it into the database. So let's clear that out and let's go back to our back end and let's run dt again. And now we have our stock data table. It doesn't have anything in it, but we do have our stock data table. We can show that it doesn't have anything in it by running a very simple query. We're going to do select star, which is select everything, from stock underscore data. And that is just going to show us any data that is currently in that table. And it shows us our column names as we created them before, and it shows us that we have no rows, which we expected. We haven't pushed anything to it yet. So let's actually push something to it. Fairly simple. Let's go back up here and we're going to copy paste our data structure. I'm actually going to cut it. And we're going to go down here. Basically, this right here is where we're actually going to want to commit all of this stuff to our table. Commit to table. And here's why. Basically, this is the end of our loop. This is when all of the relevant variables have been created in our objects. So we're going to create an empty object. And we're going to paste up here our data structure. Let's format that so it doesn't look so ugly. All right, so we've got our object right here, and here are the pieces of data that we actually want in it. And I've gone ahead and placed an X next to the things we already have. So we already have the ticker that's up here in our main loop. We've got the price and the delta. We're pulling those off of the pages. Now all we need to do is create a UUID and a timestamp, and we're going to load all of this information into an object and push that to our database. So the timestamp is actually the easiest. That's timestamp is equal to, and we're going to do time.local time. That's going to get our time, and then we need to format it. Let's do dot string, well, let's just store that and then format it. Time formatted is equal to timestamp dot string from, and I'm looking at my notes here because it is a weird way to do it. And here's our formatter, and we're going to pass in timestamp. So our format, let's just do hours underscore minutes underscore seconds. And let's comment this out real quick, make sure that that is what we actually want. We're going to do timestamp time underscore format. So let's see what that looks like, make sure that it's something that we actually might like. Oh, I've got time.string from time. Let's try and run that again. So 22 underscore 41 underscore 33. Wouldn't say it's pretty, but so that'll give us our timestamp. We want our UUID now. So our UUID, basically what we're going to do is just make it equal to our ticker, and then an underscore, and then our time underscore formatted. that is going to basically guarantee that we're going to have a unique ID every single time. The reason being is that the way we're doing this here is we're creating a unique ID based on the time, and it's down to the second. It's not down to the millisecond. We could do it a little bit more granularly, but for right now we've got it down to the second. And basically what that means is that as long as we are not scraping two different pages on the exact same second and storing that variable, that timestamp variable at the exact same second with the exact same ticker name, we're not going to get clashing UUIDs. We're not going to get two of the exact same UUIDs. And because we go down here and we sleep for a second, that's going to be virtually impossible. There's no way that we're actually going to get any kind of UUID clashing or duplicate unique IDs. So we should be good there. I'm not super worried about that. So we've got our UUID and we've got our timestamp. So now that we've got all of that information, we've got our UUID, we've got our timestamp, we've got everything just perfectly figured out, we're going to actually create our object here. We're going to uncomment this, and we are going to create what is going to become the object that we actually push to the database. So we've got UUID, set that equal to UUID. We've got ticker, set that equal to ticker, which we instantiated way up here at the very top of our for loop. We've got our price, which is equal to price, which we scrape from the page right up here. And then we've got our delta, which we scraped right here. And delta. Now, it's very, very important that all of these names right here match your column names in your database itself. So I'm going to show you right back here. So these are our column names. We've got to make sure that the names in this object that we're creating match those perfectly. Otherwise, we are going to be running into problems later on. So we've got our object created. Now we are going to create our query. So just like before, I'm going to write out our query first, and then I will explain it afterwards. We're going to name it push query equal to... All right, so let me write that out, and then I will explain it after I'm done. All right, so I've written out the query here, and let's explain it. So we're inserting data. So it's insert. We're inserting it into the stock data table. So insert into stock underscore data. And here we are listing the order and the values that we're inserting. So we are inserting a UUID, a timestamp, a ticker, a price, and a delta. I actually forgot to include the timestamp up here. It's time underscore formatted that we're using. Okay, so we've got all of that information. This is the order that we're going to be pushing it into. So UUID, timestamp, ticker, price, delta. And then we are going to list the values. Now we're using Python string formatting here, which is going to make a lot more sense here in a second. But essentially these %s's need to match the number of variables that we're inserting. So we've got 1, 2, 3, 4, 5 variables. 1, 2, 3, 4, 5 string formatters. So now we're going to actually run our query. So cur.execute, just like before. We are going to insert our push query, and then here's where we're actually going to insert our variables into that, that string formatter. So we are going to pass in UUID. Well, actually, so we didn't technically need to do this up here, and I'll kind of explain why I did do it this way. A lot of other database technologies will actually just take raw JSON as like the way that you insert it into the database. I'm kind of used to doing it that way, so I create objects with all of that information just kind of laid out within one object. You technically could just grab it from these variables up here and do it that way, and it's probably an easier way to do it. But this is just kind of the way that I'm used to thinking. It kind of makes sure, like this turns into a shopping list, essentially, to make sure that I've got all of those variables, they're all named correctly, and they're all formatted correctly. So in order to access it, I'm going to use UID, and we're just going to copy paste this. 2, 3, 4, 5. Our next one is the timestamp. Then after that is the ticker. Then after that is the price. And then after that is the delta. So basically, like I said, it just turns it into a shopping list, and it makes sure that all of my data is all in one kind of like perfected form. It's also because I'm used to creating APIs of my own in order to insert this data into the database. So I send on a JSON object instead of like inserting it directly into the database. So it's just kind of, I guess, a bad or dumb habit that I've gotten into. So let's do con.commit. Since we're doing a write, we want to do that. And then it's going to sleep directly afterwards. So this is a big moment. It's the moment that we're actually saving stuff into a database for the first time. It's scraped data that we're saving into our own database. It's exciting, it's cool, and it's also going to be kind of boring because I'm recording this at about 11 o'clock p.m. my time, and the markets are closed. So all of the prices are going to be, the exact same as they were at market close. There's not going to be too much price difference there. But it is going to basically show us that it is going to work, and we can run this later on, on our actual data while the stock market is running. So let's clear this out. Just so you know that I'm not faking this, let's run this query again. So here are rows. So we don't have any data in our table as of right now. Now let's run our scraper and see if we are able to successfully push this data to the table. Run it. Seems like it's working thus far. We're getting all of the data down. And we're done. Now, the moment of truth. Let's see. Select star from stock data. And we have our data. So as you can see, we've got our UUIDs. That is our stock ticker plus our timestamp, plus an underscore plus our timestamp. Then we've got our timestamp, we've got the ticker, we've got our price right here, and we've got our delta. Now, obviously, again, all of this is not like the perfected way that you should do this. There's probably a better format for our UUIDs. It's kind of ugly. Our timestamp is not very granular at all. It's down to the second instead of the millisecond, which is like 1 second in stock trading time is like an eternity. Tickers are probably fine. Our price could be a double or a float instead of just a string. Like I said, not the best way to do it. Our delta is super ugly. It's basically storing the actual monetary delta and the percentage delta within the same column. Probably not the best way to do things, but again, it works, so who cares? So we've got 5 rows here, which makes sense because we've got 5 different stock tickers. Now, here's a very quick way to make this something that's actually useful. If we go down here and we do while true. So this is going to create an infinite loop, and we're going to take everything within our for loop, and we're going to indent it. And what this is going to do, oh, that's not the right way to do that. So let's just do it the old-fashioned way. Scroll all the way down to our wait, or our sleep. So we're going to indent all of that, and we're actually going to do a second sleep to sleep in between batches. So let's just do a 2-second sleep there. And let's print something. Batch done. And what this is going to do is it's going to change it from something that just runs one time every time you click go to something that runs continuously throughout the day. So once we run that, it's going to run through the exact same thing. We're going to be pulling all of the data down, blah, 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 blah. And we'll get to the end where it says batch done. We're going to wait a little while, and then it's going to run all over again. So think running this for multiple days and pulling all of that data down, and it's exactly what we're looking for in stock price analysis. And if we go down here to our database itself, we can instead just select the count, so it's not going to print out all of the data. Count, if I can spell, and click go, and it's 24 rows right now, 25, and it's going to keep increasing as time goes on. But if you didn't have an endless loop, if you had something that actually exited gracefully and things like that, you would want to close the connection, just because otherwise you get unlimited hung connections. That's not really something that you want. So Done. We're saving data to a database. We've got it converted over to something that we can run all day. Honestly, I feel a little bit uncomfortable with the very short sleep cycles we've got here. I would probably change this to 5 seconds in between batches, maybe 2 seconds in between tickers, maybe a little bit more than that if you were running it all day. Like I said, it's kind of arbitrary, but it is a good thing to increase those deltas as much as possible. We're not using this for anything really, but unless we were using it for something like, incredibly high frequency stock trading, in that case, you don't want to be using Yahoo Finance. You want to get like your own private API and fun stuff like that. But, in the hypothetical that we are doing that, you would want to decrease that delta as much as possible, that sleep period as much as possible. But, with this case, since we're not actually using this data, we probably could increase that to 5 and increase this to 10, if we were to run it all day, because we don't really need like super granular data if we're not actually going to use the data. That is it. The next section is going to be way more advanced. We're going to be going over spiders. We're going to be going over much more complex designs. Some code that's going to look like absolute spaghetti at first, but it's going to be really fun and really interesting. Thank you guys so much for sticking through this monster of a video. I've got like 40 minutes of record time. So thank you guys so much for sticking with it. I know it can seem kind of weird that we're kind of gathering all of this data for no purpose, but it's teaching us very valuable stuff. We're kind of going from absolute zero to saving stuff to text files to actually saving stuff to databases that we can later go into and start analyzing data for. So you've come a long way already. This is, we're only going to get more advanced, and the next section is going to be really, really cool. So like I've said before, it helps a whole lot if you tell me what I'm doing right and what I'm doing wrong in the course reviews if you're on Udemy, or in the comments if you're on YouTube. I'm going to be updating this and creating new content for this course over time. So it actually helps a ton in a myriad of different ways if you go back in and review, or tell me what I'm doing wrong, what I'm doing right, whatever you really want to tell me. Thank you so much, and I look forward to the wrap-up video next, and then the next section. Peace.